Hello, everybody, and welcome to Transportation Innovation Days, a multi-webinar series where we have an amazing amount of information to cover for you. Today, we're specifically covering ADAS, but before we get into that, I'd like to introduce our guest, Matt, the VP of Automotive here at Microchip. How are you doing today, Matt?
Thank you, Cliff. I'm doing fine.
Good to hear. So we have wonderful information. Before we get to that, some housekeeping and logistics. We are live streaming on Facebook, YouTube, and LinkedIn. And furthermore, if you guys have any questions during this event, feel free to email us at livestream@microchip.com, and I will make sure that the email goes out to the relevant party. So without further ado, Matt, what direction do we see the automotive semiconductor market going?
Well, it's trending upwards. The automotive semiconductor market is expected to grow from $45 billion in 2021 all the way to $61 billion in 2025, and expected to double all the way until 2030. So tremendous growth expected in the automotive semiconductor industry.
Absolutely. And so where do we see Microchip in this industry specifically?
Microchip is one of the leading players in this industry with a revenue of north of $1 billion annually. This represents about 15% of the company's sale. And what is very important in a relatively conservative industry, we are a trusted supplier to our clients for over 25 years.
Nice. And so what sort of megatrends has Microchip identified in relation to this?
Well, globally, Microchip has identified 6 megatrends. Data centers will grow tremendously over the coming years. 5G, especially the infrastructure, IoT and edge computing, AI and machine learning, and 2 of the 6 megatrends, electric vehicles and ADAS and autonomous driving, are automotive megatrends exclusively. All of those megatrends tie together, and they tie into the automotive section. There is no ADAS possible without 5G. There is no ADAS possible without high-speed computing that you today find in data centers. There's no ADAS possible without machine learning and artificial intelligence. So all of the megatrends that we have identified driving growth for the company in automotive and in other markets also tie back into the automotive market.
Nice. And so diving a little bit further into the automotive market, what sort of changes do we see in the coming years?
I believe the changes are very large, very tremendous. If you look in the past, a car was defined by the hardware. How does it handle the power, torque, speed, number of cylinders, sound of the engine? This is how car buyers looked at cars in the past, and those figures were the important ones. But there is an important paradigm shift. In future, cars are no longer defined by the hardware. Hardware is a given. The future cars, they are software defined, enabling things like ADAS, very advanced infotainment with streaming, over-the-air upgrades, personalization. So in future, a car that is delivered from the dealer will be able to get features over the lifetime, over-the-air updates. And those features can result in additional services that the car maker can monetize, can sell or license to the buyer or owner of the car. Just to give you one example, if your car is equipped with sensors that allow the car to drive in a dense traffic environment on its own, the car could offer to drive you for free for the next 20 miles to try it out. And next time you're stuck in a traffic jam in the morning, it can offer this as a service. So there are new service models and streams being developed by the car makers.
Nice. And so you've mentioned autonomous drive like we have on the slide. Is there any sort of difference between driving automation and autonomous driving?
Yes, absolutely. You're right. Good question, Cliff. The difference is the level of autonomy. If you look at driving automation systems, there are many individual systems that assist the driver. For example, lane keeping assistant, lane departure assistant, front collision avoidance systems, etc. But they're all kind of individual systems that help to drive, but the driver still needs to be able to take control of the car. Those are level 1 and level 2 systems. The entire level of autonomy is increasing from level 1 to level 5. Level 5 means it's a driving pod, no steering wheel required anymore. And level 2 is what we are seeing about today on the roads. A lot of assist systems, pretty capable ones, but the driver needs to be alerted all the time. That's why one of the assist systems is also, for example, a hands-off detection on the steering wheel. So the car must alert the driver when he's not paying attention. So there are sensors that are built into the steering wheel, passive sensors that detect whether the driver is holding the steering wheel or not. So this is part of an assist system to keep the car safe. All those systems require that the car has senses like a human being.
So there's a tremendous number of sensors required to achieve this. What sort of sensors in particular are we talking about?
Those are the senses that human beings got as well. Vision first and foremost. So there are image sensors, cameras. But the advantage of technology is that we have more. We can put radar into a car, a sense that a human being doesn't have. We can put LiDAR into a car, ultrasonic sensing, and even the hearing sense will be put into cars at a higher level of autonomy. Microphones at the outside of the car that detect, for example, the sound of a fire engine or an ambulance or a police car, because the autonomous car also needs to react to those sounds. With the increasing number of sensors, the complexity in terms of hardware as well as software is increasing tremendously. Software is never perfect, so there's a requirement to be able to update the software over the lifetime of the car, either to fix bugs or to add additional services or additional capabilities to the cars with the sensors. All that complexity is increasing so fast that changes are required to keep the development time and the development cost of a new car until it hits the road at a certain level, otherwise it would explode.
Well, we certainly don't want anything to explode. The last bullet point on your slide has to do with architecture changes. Do you mind diving in a little bit deeper about what sort of things has to change within a vehicle to achieve these sort of things?
Sure, no problem. One of the reasons for the rapidly increasing complexity in car architectures is the amount of different networks that are used inside the car. And they all speak their own language. They need to be translated to understand each other. So it would be a lot easier to have one network with one common software language at different speed rates. And this is Ethernet. The industry believes that they can reduce the amount of development time and reduce the amount of development dollars until a car hits the road by using less different networks and to introduce Ethernet inside the car. This required architecture changes. The main zone controllers that are bundling functions in a geographic zone inside the car together are interconnected using Ethernet, 100 base T1 or 1000 base T1, while the edge nodes will in future be connected with the new Ethernet standard. It's called 10 base T1S. It's a low speed, 10 megabit, true network. So it's not point to point, but it's point to multi-point. And this will reduce the software complexity developing a new car.
And so on the slide we have Ethernet 100 to 1000, and the 1000 means 1000 megabits, which is a phenomenal amount of information. But is that enough for L3 and the other higher echelons of driving autonomy?
Cliff, you're absolutely right. 1000 megabits sounds like a lot. It is a lot, but it's by far not good enough to transport and to process all the data that is required for higher levels of autonomy. The car basically for level 3 and beyond, and beware, level 3 still requires driver attention, driver interaction, requires a lot of processing power. it requires fusing the different sensor information from different cameras, fusing it with LiDAR, with radar information, and to have a centralized decision making, which requires high-speed computing inside the car, and with that, high-speed data throughput. Basically, a car becomes a data center on wheels.
Nice. And so the last slide you mentioned the high-speed data. How do we actually achieve that sort of speed?
Well, if you look at the architecture of the car, there will be central processing units, like in the server. There will not be only one, there will be several of them for different types of ADAS applications, but also for redundancy, because you need the safety element. Once the car is driving you, you need to be relaxed and at rest that the car is doing a proper job, even if a component fails. So those high-speed SoCs, or brains of the car, need to be interconnected. And the technology of choice to interconnect SoCs amongst each other, but also to hook them up with high-speed memory, which is needed to buffer, for example, data from high-speed image sensors, is PCI Express. PCI Express is a technology that is used today in data centers. We're currently at the 4th generation of PCI Express, and one single lane of PCI Express has a speed of 16 gigabit per second, or per lane as it is called in this standard. And we have qualified chips for automotive, PCI Express switches for automotive, that support up to 54 lanes, means 54 times 16 gigabit per second. This is the amount of data we're talking about that is required to get close to full autonomy in a car.
Nice. And so it's really sort of awesome technology, and ADAS is inherently about safety, but how do we actually secure this level of technology?
Absolutely. Security is paramount. There is no safety without security. So the individual systems, especially the access doors to the car, need to be secured. Microchip has a very long history in the security market, and we have developed dedicated products that can secure individual automotive systems. They're certified to the highest level of security, even according to banking standards. In addition, we do have products that have built-in security, like hardware security modules that are built into our microcontrollers, and we offer the complete portfolio of products to secure cars today, but also in the future with a higher level of autonomy.
Cool. And so during this discussion, we sort of focused around personal vehicles, and I think the discussion around ADAS in general sort of revolves around personal vehicles. Where else do we see this sort of technology coming up?
ADAS is about autonomy, and autonomy is not only relevant for passenger cars. Autonomy is relevant for all vehicles or objects that are moving without interaction, that need to have a certain intelligence built in, some learning built in, to be able to cope with their jobs. It could be drones for delivery, for example, fully autonomous agriculture equipment, personal robots, people movers, during the pandemic, robots that disinfect certain locations, to more simple things like lawnmowers or automatic parcel movers in logistics centers. So all of those autonomous objects require very similar technology to be able to do their job. So there's a secondary market for whatever is being developed for automotive.
Cool. It's pretty exciting technology. We're going to see it everywhere in the future. And that brings us to a close of the actual presentation portion. I'd like to thank you very much, Matt. You have been wonderful. Before we go, I'd like to show you all what else you can expect from the Transportation Innovation Day series. We have multiple different days, multiple different seminars, and if you click this link, which we're going to have in the description, in the comments, and if you cannot find it, just email us at livestream@microchip.com. Once you click this link, you'll be taken to this page where you can register for the rest of the event. And you'll also have access to a whole bunch of other information that we have already done and are going to do in the future. It's a wonderful amount of information. Be sure to check it out if you are interested. And furthermore, if you have any questions, just email us at livestream@microchip.com, like I said earlier. But that brings us to the end of our discussion today. Thank you very much for listening. I'd like to give a huge thank you to everybody who helped put this on. Once again, a big thank you to Matt. Bye.